My minimal just doesn't have the muscle for larger tools like a fly cutter or face pull. When I tried, it stripped its plastic gears. Not ideal. In this video, I'm building a custom belt drive conversion with a twist. It's not just a regular upgrade. This one's got 4 selectable speeds, ranging from ultra slow and torque heavy mode, all the way up to high speed for tiny end mills. And the best part, I didn't have to replace the motor or control board. Let me show you what I was dealing with. These milling machines can technically face mill, but only with a tool 30mm or smaller. The smallest I could find was 50mm, totally useless. When I gave it a try, the machine freaked out and, you guessed it, shredded its plastic gears. Sure, I could replace them with steel ones, but the real issue is the motor. It's rated at 350 watts. To do what I want, I'd need at least 700. But once you upgrade the motor, the dominoes start falling. First, the control board needs replacing. Then, you need to swap out the plastic gears for steel. After that, you hit another wall. The top speed isn't high enough for small end mills. For example, a 2mm end mill needs around 4800 RPM, and this mill maxes out at 2500. Worse, the control board often cuts power mid-operation. To protect the motor, especially with large drill bits or countersinks. In short, mini mills are great for small end mills and drills under 12mm, and not much else. If you're like me, you want more from your machine. So, what are the options? Upgrade the motor, more torque, sure, but now you need steel gears and a new control board, and you're still stuck with limited speeds. Buy a belt drive conversion kit. Most top out at 4300 RPM, but they lack the low speed grunt needed for fly cutting. Buy a bigger mill? I wish, but I work in a 5 square meter mini workshop. No room for a monster machine. So, I came up with my own solution. I built a custom 4-speed belt drive conversion. It's quiet, powerful, and gives me 640 RPM for large diameter tools and torque heavy jobs, 1100 for drilling, 1800 for general milling, 3100 for tiny end mills. Thanks to the gear ratios, I'm getting torque like a 700 watt machine, without changing the motor. If you think this is a great idea, give it the thumbs up by clicking the like button. I'll be tracking the popularity of each idea and will share the results in an upcoming video. Let's take a closer look at the parts that make up the belt drive and how it all fits together. The base plate holds the motor and tensioning system. It bolts straight to the mill head. The spindle pulley mounts onto the spindle and locks down with a left threaded nut. It features a locking hole that allows a spindle to be locked to the base plate using the locking bar. The motor pulley even has built-in cooling fins to cool the motor as it runs. Now the motor with its pulley is mounted onto the base plate. The intermediate pulley spins on two bearings fitted to a shaft. A spacer and Allen bolt secures a pulley in place, preventing the pulley from slipping out of its bearings. A floating plate mounted to the tensioning plate balances tension across both belts, so only one tensioning mechanism is needed. The intermediate pulley hangs from this floating plate. The swing arm tensioning plate pivots at the thumb bolt and locks in place with a locking lever. Simple, solid, and effective. Let's test the solution and see how it performs. The slowest speed is 640 rpm, perfect for driving a large diameter fly cutter slowly but with plenty of torque. The faceplate shows the correct belt positions for each speed setting, making it easy to mount the belts on the pulley. The motor barely notices the load. At this speed, fly cutting and face milling are totally doable. The surface finish is smooth with no sign of strains from the milling machine. And now for the big test with the face mill, designed to hog off thick sections of metal with deep cuts. I am taking a heavy cut of 1.5 millimeter or 60 thou, something this mill was never designed for, but it powers through without flinching, and no power cuts from the control board. This would have been impossible without the super slow and torque heavy capability. Well done, little milling machine. Maybe I'll push it even further in a future video. Now let's jump to the other end, a 3100 RPM. That's the new maximum speed, a 24% bump over the original 2500. A 2mm end mill like this would normally snap without the right speed, but with high RPM and careful feeds, it runs beautifully. Surprisingly, it also allows for a relatively high feed speed at this 1.5mm or 60 thou depth of cut. With that problem solved, I've got more ideas in the works. Want to see what's next? Click on the link at the end of this video to check out my next idea. I think you'll like it. Don't forget to subscribe if you want to see more upgrades like this. Thanks for watching. I hope you found this idea useful and can put it to good use in your DIY workshop. See you next time.